Good afternoon to one and all. I am R.V. Kiran, Assistant Professor, Department of Mechanical Engineering. So, today's class is on fits and its types in the subject of metrology, and this is my second lecture regarding to the subject metrology. So in the previous class we have seen about different types of limits and fits. So what are the functions of limits and fits? So how do they evaluate in the manufacturing process? So there are key functional requirements and fits being the mating parts. So these are all the design for manufacturing parts. The next one, what is the evaluation for limits and fits? Next, we have seen some of the short answers, that is precision and accuracy, and we have seen a pictorial representation of this accuracy and precision, and we have seen some of the terms and definitions of the limits and fits. That includes the deviations of the limits and fits. Today, we are going to see about the fits. So types of fits. So what are the basic types of fits and how many types of fits have been evaluated through this hole and shaft. So first of all, what is a fit? So generally fit is the defined as the relationship between the two mating parts with respect to the amount of interference. So with respect to the amount of interference in the fits. So which is represented at the time of assembly. So at the time of assembly, they are representing these positions. And it is the degree of tightness or looseness between the two mating parts. So we can define a fit by this term, that is called as tightness or looseness of a two mating parts to perform a definite function. So to perform a definite function between the two mating parts, it is the degree of tightness or looseness. Next, it is the relation between dimensions of the two mating parts before their assembly. So the relation between these two mating parts can be assembled in their parts. So this can be assembled wherever they can. So the minimum clearance and the maximum clearance has been taken into an account. The tolerance can also play a vital role in the fits. So in the different types of fits. So here in the picture, you can see the hole tolerance and the shaft tolerance and different types of clearances, that is minimum clearance and the maximum clearance of the shaft and hole. So these fits are all based on the degree of tightness or looseness. So when we choose a fit, it is either in the tightness side or looseness side between the two mating parts. So the relation between the dimensions of these two mating parts can before their assembly. So when we are going to assemble the two mating parts, we are going to done these types of fits. So in the picture, you can see the hole and a shaft which is interfering in both the sides. So here a shaft is fitted into a hole and the minimum clearance is the gap between the shaft and hole. So this is the minimum clearance here and the maximum metal position is the shaft position and the minimum metal position is the shaft position with taking an account to the minimum clearance also. So each individual tolerance has been done to the hole and shaft, that is the hole tolerance and the shaft tolerance. So you can see it in the picture also. So these observes the types of fits. Next we have to the classify the types of fits. So first one is the clearance fit, second one is the interference fit, and third one is the transition fit. So let's see the first one, that is the clearance fit. So a fit that always provides a clearance between the hole and shaft when they are assembled is known as the clearance fit. So a clearance means a gap between the shaft and hole. So the minimum size of the hole is greater than the extreme size or maximum size of the shaft. That is the shaft size diameter. That is the shaft diameter size is less than the hole external diameter. Next, we have to see the minimum clearance and the maximum clearance. So, in a clearance fit, the positive difference between the main difference between the minimum limit of size of the hole and the maximum limit of size of the shaft is known as the minimum clearance. So, the minimum clearance is all about the minimum size of the hole and the maximum size of the shaft. So in the picture you can see the minimum clearance. So this is the minimum clearance. So from the outside diameter of the shaft to the inside diameter of the hole. So that is the positiveness, that is known as minimum clearance. And in the maximum clearance you can see the difference between the maximum limit of the size of the hole and the minimum limit of the size of the shaft, minimum limit of the size of the shaft. So that is known as maximum clearance. So in a clearance or transition fit, the positive difference between the maximum limit of size of the hole and the minimum limit of size of the shaft is known as maximum clearance. So these are the two types of clearances we have seen in the clearance fit. So in the picture you can see the tolerance zones of these clearance fits. So in the black color you can see the shaft tolerance and in the purple color you can see the hole tolerance. So here you can see the maximum clearance and the minimum clearance, it is indicated as C, that is maximum C and minimum C. So for the maximum clearance, the upper limit of the hole is difference of the lower limit of the shaft, and in the minimum clearance, the difference between the lower limit of the hole and the upper limit of the shaft. So these tolerance zones has never met because they vary in the sizes and the tolerance zones, so they can never meet in the tolerance limits. Next we are going to see the interference fit, that is also called as press or force fit. So interference means extended part. So that is the extended part of the shaft. So in this interference fit, the outside diameter of the shaft is greater than the hole. So that is the size of the shaft is larger than the hole. A fit which everywhere provides an interference between the hole and shaft when it is assembled. That is, the maximum size of the hole is either smaller than or in the extreme case equal to the minimum size of the shaft. So, in the maximum chances, the maximum size of the hole is lesser than the shaft size, lesser than the shaft size. So in these interference units, we are going to see the two types of interferences. First one is the minimum interference, and second one is the maximum interference. So in a minimum interference, in an interference unit, the negative difference before the assembly and between the maximum limit of the size and the hole and the minimum limit of size of the shaft. So that is the basic difference there for the minimum interference. So the maximum limit of size of hole and the minimum limit of size of the shaft. So that is the minimum interference. For the maximum interference, it is an interference or transition unit fit. The negative difference before the assembly is between the minimum limit of size of the hole and the maximum limit of size of the shaft. So it is the minimum limit of size of the hole and maximum limit of size of the shaft. So that is due to the maximum interference and the minimum interference of the interference unit. So this is the pictorial representation of the interference fit. You can see the maximum interference and the minimum interference of the two fits. So the brown color portion is the interference limits of the hole and the shaft. So the maximum interference is less than the minimum interference. So here you can see it in the picture also. the minimum interference of the shaft is larger than the maximum interference of the hole. So this refers to the shaft size is larger than the hole size. So we need to make certain changes to assemble the two mating parts, that is the shaft and hole. So here mating parts means a hole and a shaft. Next, last one is the transition fit. So in the transition fit, the fit which may provide either a clearance or an interference between the hole and shaft when assembled together. So that depends on the actual sizes of the hole and shaft, that is the tolerance zones of the hole and shaft overlap completely or in the part. So this fit may be piece to piece fit, that is the shaft size is equal to the hole size. So that is the outside diameter of the shaft is equal to the position of inside diameter of the hole. So you can see it in the picture that so the transition fit, hole and shaft dimensions. So the hole diameter is constant and the shaft diameter is also constant in this type, and the shaft and hole tolerance should be 0, that is equal to the part of the hole and shaft. So by obtaining the overlapping of tolerance zone of the shaft and hole, it does not vary neither clearance or interference bit. So it is in between the clearance bit and interference bit, that is the it is the intermediate portion of the clearance and interference bit. So this is regarding the transition fit. So there are upper deviation and the lower deviation according to the fundamental deviation. So this fundamental deviation is on the red color line. So that is to the basic size. So when a shaft is fitted or assembled in the mating part, the maximum size and minimum size of the shaft has been seen here. So you can see the tolerance grade also. So the blue color line indicates the tolerance grade limit, and it is the international tolerance grade. So the international tolerance grade have been referred to as difference between the shaft and hole. So you can see the difference here. The basic size, the fundamental deviation is seen as the gap between the hole and the shaft, that is the tolerance limit. But in the modified version, you can see the fundamental deviation limits is extended. So that is come outside of the hole and the upper deviation and lower deviation also changes its dimension, and the minimum size of the shaft is less than the minimum size of the hole, and the maximum size of the shaft is also less than the maximum size of the hole. Next we can see the some terms and conditions regarding to the fits. First one is the maximum material condition. In this maximum material conditions, the condition where a size features contains the maximum amount of material in the stated limits of size, that is the largest shaft and the smallest hole. So this maximum material condition refers to the maximum amount of the material within the size limits, that is the largest shaft and the smallest hole. And next coming to the least material condition, that is the LMC, that is least material condition. So in this condition, a size feature contains the less amount of material in the stated limits of size, that is the smallest shaft and the largest hole, which is the quite difference between the two material conditions, that is the maximum material condition and the least material condition. Next, coming to the tolerance, that is the difference between the maximum material condition and least material condition, in which the limits of a single dimension. So it when we take as a single dimension. Last one is the allowance between the parts. So allowance between the mating parts. So that is the basic difference between the maximum material condition of the two mating parts. That is the minimum clearance and maximum interference. So this refers to the basic difference of the maximum material condition of two mating parts. That is the hole and shaft. So we can take it as minimum clearance and maximum interference.